So Q at point A. So let's consider point A first, okay? So Q at point A. So the width is equal to 30. The depth is equal to 20. And the Y bar is 20, 40. So 20, so it's 40 plus by 20 divided by 2. Okay, so 40 plus by 20 divided by 2 times by 20 times by 30 is equal to 30 times 10 to the power 3 millimeter cube. Okay, or 30 times 10 to the power minus 6 meter cube. Let me do it again. 40 plus by 20 divided by 2 plus by 20 times. No. By 20 divided by 2 times by 20 times by 30 is equal to 30. Okay. So from here, at A, the thickness is equal to what? 0.03 meters. Right, that's the thickness. So the QA over T is equal to 30 times 10 to the power minus 6 divided by 0.03. Okay. So 30 power minus 6 divided by 0.03 is equal to 1 times 10 to the power minus 3. Let me do it again. 30 power minus 6 divided by 0.03, which is so 1 times 10. Okay, it's correct. So next we consider point B. Point B thickness is equal to what? So if you look at thickness, it's equal to 60. So 0.06 meters. So the Q at point B is equal to the Q of point A plus, so the width is what? 60. The depth is 20. The Y bar is 20 plus by 20 divided by 2. Okay. So this will be equal to 30 times 10 to the power 3 plus. So 20 plus by 20 divided by 2 times by 20 times by 60 is equal to 36 times 10 to the power 3. Okay. So 20 plus by 20 divided by 2 times by 20 times by 60, 36. So this will be equal to 66 times 10 to the power 3 millimeter cube, or 66 times 10 to the power minus 6 meter cube. So the QB over T will be equal to 66 times 10 to the power minus 6, and then the thickness is now 0.06. Okay, so 66 power minus 6 divided by 0.06. Now this is 1.1. So what we realize is now, if we don't consider point C, point B has the higher ratio now, right? You can see that. I think you all can see that for yourself. Okay, and then finally we take it at the neutral axis. So at point C, now the thickness is equal to what? 30 on each side, so it's 0.09 meters now. So Q at point C is equal to Q at point B plus the width is equal to what? 90. The depth is equal to 20, and this is 20 divided by 2 now. Okay, so Q at B is equal to 66 times 10 to the power 3 plus by 90 times 20 times 10, which is 18 times 10 to the power 3. So 66 power 3 plus by 18 power 3 is equal to 84, right? Times 10 to the power 3 millimeter cube, or 84 times 10 to the power minus 6 meter cube. Okay. 84. Okay. So finally, you look at the QC at point C over T. So this is 84 times 10 to the power minus 6 divided by the thickness, which is 0.09. Okay. So 84 power minus 6 divided by 0.09. 84 power minus 6 divided by 0.09 is equal to 84 power minus 6 divided by 0.09. 66 power minus 6 divided by 0.06 is equal to 1. Okay. 84 power minus 6 divided by 0.09 is equal to 0.933. Okay, times 10 to the power minus. So where the maximum stress will occur at point B, right? Maximum stress will occur at point B, right? Why? Because if you look at these ratios over here, right? If you were to look at these ratios over here, this is at point A is 1, point B is 1.1, point C is 0.933. Okay. So the question asks us, we are almost done. Okay, bear me some time. The question asks us to determine the largest shearing stress. So we know that tau max occur at point B. Okay, so this is our point A, point B, and at the center is our point C. So therefore, V shear XY at point B will be equal. So our Vy is what? Our Vy is, can't remember now. Our Vy is 46.957. Okay, 46.957 times 10 to the power 3. Our IZZ, which we calculated, is 5.76. Okay, 5.76. And then we use at point B, the ratio is 1.1 times 10 to the power minus 3. Okay. So 46.957 power 3 times 1.1 power minus 3 divided by 5.76 power minus 6 is equal to 8.967 times 10 to the power 6 Pascal. And then at point A, the tau max at point A, or tau at point A is equal to 46.957 times 10 to the power 3. And then we divide by 5.76 times 10 to the power minus 6. And then we multiply by 1. Okay. 1 times 10 to the power minus 3. So this will be equal to 46.957 power 3 times 1 power minus 3 divided by 5.76 power minus 6 is equal to 8.152 times 10 to the power 6 Pascal. And for this case, since I think I have 2 more minutes, okay, shear XY at point C. Okay, in fact, the centroid has the lowest shearing stress now. Okay, so it's 46.957 times 10 to the power 3 divided by 5.76 times 10 to the power minus 6 multiplied by 0.933 now times 10 to the power minus 3. Okay, so 46.957 power 3 divided by 5.76 power minus 6, then 9 point, not 9, multiplied by 0.99, 0.933 power minus 3, 7.606 times 10 to the power 6 Pascal. Okay, that's all for today. Thank you for your time and attention. And homework is posted. It's due the following Friday. Okay, I'm going to stop recording now. Thank you.